Now in this video we will discuss the next question of the remaining question of the exercise 9.2. In this exercise we are studying about the integration with substitution, and some parts we have already solved and some are remaining. So let's start the exercise 9.2 from the question number 8. But before the starting of this exercise, before the starting today's lesson, wants to tell you some basic formulas which are related with the substitution with this exercise. Actually, in the exercise 9.1 we have discussed most of the formulas, but some are remaining which are we did not discuss in that exercise. Integration of 10x, second integration of cot x, third integration of sec x, fourth integration of cosec x. Actually, sin x and cos x, about the sin x and cos x we already know. Sin x, integration of the sin x is minus cos x, and integration of cos x is sin x. But about these formulas we did not discuss. What is the reason for behind it? Because tan x is not a differentiate value of any function, क्योंकि tan x किसी का differentiation नहीं है. तो in the last exercise we discussed that formulas for which we note the differentiate values, but tan x is not a differentiation of any function, cot x is not a function differentiation of any function, and sec x is also, and cosec x is also not a direct differentiation function according to the differentiation formula. So that's why we did not discuss. So now we are going to discuss about these four formulas. First, actually इंटीग्रेशन को अपन इंटीग्रेशन को I से डिनोट करते हैं. सो लेट I is equals to under root of tan x dx, and we know that tan x is equals to sin x upon cos x. Tan x is equals to sin x upon cos x. At this time we will apply the method of substitution. So let's suppose, and in this case I am considering that cos x is equals to t. Actually cos x को अपन t मानेंगे, then the differentiation of cos x will be minus sin x, and minus sin x is available, means that this function is in this formation f(x) into f dash x dx. A function is given and its differentiate value is also available, then you will consider the f(x) as your substitute value, and you will also think that cos x is also available and it is the differentiation of the sin x. So you can consider this one also as your substitution, and to make it more easier I am using this, and after this process we will use this one as substitution. So let's proceed. Again let cos x is equals to t, and differentiation of cos x is equals to minus sin x, and differentiation of x is dx is equals to dt. What it? Actually हमने differentiation क्यों किया? Why we are doing the differentiation? We are changing cos x into t, means our new variable will become t. ये t हो जाएगा. So we will remove this x also. Cos x is equals to t, but this x is available and dx is also available. So we will try to remove this one x and this one also. That's why dx is the differentiation. That's why we are doing the differentiation of this function. Are you getting my point? Next implies that dx is equals to minus dt upon sine of x. Are you agree? Let's suppose it is the equation number first and this is the equation number second. On applying or substituting the values of cos x and dx into equation first. Dx from here and cos x from here. Cos x is equals to, then your integration will become I is equals to, at this time sin x will be remain same because we do not have the value of sin x, upon cos x is t and dx is equals to minus dt upon sin x, minus dt upon sin x. Sin x cancel by sin x, finally we get minus dt upon t, and the remaining part I am solving here. I is equals to this, I is equals to minus 1 upon t dt. Finally I is equals to minus log of t. Clear? Minus log of t implies that. Now it is our assumption, so we cannot consider t in our answer. So to remove t, again apply the value of t. T was cos x. It is minus log of cos x plus c, and we know it can be written this formation also, log cos x inverse plus c, माइनस पावर में आ जाएगा. क्लियर? cos x inverse is equals to 1 upon cos x, which is equals to log of sec x plus c. So this is the formula of tan x. Both are the formula of this one and this one of tan x, but mostly we will use this one. Tan integration of tan x is equals to log sec x plus c. I think you are getting my point. Now let's suppose I am doing again. Let's suppose if someone want to consider sin x as t, because cos x is also available, let sin x is equals to t. Then to calculate the value of dx, differentiate this, then it will become cos x dx is equals to dt. Implies that dx is equals to dt upon cos x. But if sin x is equals to t, if sin x is equals to t, then we know that cos x will be under root 1 minus t square. Using the identity sin square x plus cos square x is equals to 1. Now this value of cos x and this value of dx apply in the equation number first. So write the statement on applying the values of cos x and dx in equation first. This time, this one, and this one sin x also. Then your integration will become sin x is t. Sin x is t. Upon cos x is 1 minus t square. 1 minus t square into dx. Sorry, this is not. Sin x is t. dx is dt upon cos x. dt upon cos x, and this cos x also here is equals to t into dt upon cos square x, where cos x is equals to under root 1 minus t square, then cos square x is equals to 1 minus t square, t into dt upon 1 minus t square. Clear this thing? Now student, again we will use the substitution. Substitution is a chain process, and you can apply 2 or 3 times and more than 3 times also in a same question. So I am using the second time substitution. Let 1 minus t square is equals to u. Actually, substitution is a process to make your question easy. Now I am differentiating with respect to t. Then 0 minus 2t dt is equals to du, and from here dt is equals to minus du upon 2t. Now from here it is the value of your integration. Then I is equals to t is t dt एक बार ये तो रहने दो, t 1 minus t square is equals to u into, and value of dt is equals to minus du upon 2t. Okay students, t cancel by t. Finally we get I is equals to du minus 1 upon 2 integration du upon u. Then I is equals to minus half log of u, and u is equals to half log u. U is equals to 1 minus t square. 1 minus t square, and I is equals to half log 1 minus t square. 1 minus t square t is equals to sin x. So sin square x, then 1 minus sin square x is cos square x. ये पावर हाफ है, ऊपर आ जाएगी. I is equals to minus log 1 upon 2, then cos square half cos x, and plus c also अपन ने लगाया नहीं है, इंटीग्रेशन इसका हो गया, यहां हो गया प्लस सी. Finally I is equals to log cos inverse x, cos x to the power inverse, so it is equals to sec x. So you can use any substitution. Just think about the question and force on your mind that at which value or at which substitution our question is more easier. And if in some cases you will directly think about the substitution and you can directly judge our assessment about the substitution, and in some cases your substitution is very puzzled. So don't be nervous. Imagine in your mind and evaluate in a different manner and practice makes a man perfect. Mistake होंगे 4 बार 5 बार, and if you will try again and again, one day you will get your success. So okay, the student, please note it down, and I am proceeding the next formula, which is cortex. Of sin x is equals to cos x, which is available in our function. So consider that sin x is equals to sin x is equals to t. It is our substitution. If sin x is equals to t, then on differentiating of sin x with respect to x, it will become cos x dx is equals to dt. Actually ये प्रोसेस ये होगी cos x is equals to dt upon dx, and after I multiplied cos x dx is equals to dt. So I am skipping one step from here and directly I am writing this one. Now next, cos x dx is equals to dt from equation first. Apply the value in the given equation. Your integration will become cos x dx is equals to dt upon sin x is equals to t. Next, I is equals to log integration of 1 upon t will be log of t plus c. Finally, I is equals to log t is sin x. T is sin x plus c because t is equals to sin. So it is the final answer of integration of cot x with respect to x will be log sin x plus c. Okay students, you will copy in your notebook and try to learn this formula directly and practice on this process also, because it is also the part of integration. Sometimes in the examinations this question carried 2 marks, either 3 marks also. So for the 2 marks you cannot write directly that cot x dx is equals to log sin x. You have to follow the whole of the process. So please copy this also. Now the next. Third, integration of sec x. It is little bit different from the past 2 parts. Let I is equals to इंटीग्रेशन में फर्स्ट टॉपिक आपका यही होना चाहिए कि जो भी आपको इंटीग्रेटिंग वैल्यू दे रखी है जिसका इंटीग्रेशन करना है उसको आई के इक्वल कंसीडर करते हुए चलेगा. आई इज इक्वल्स टू sec x dx. What we have to do right now? Nothing is here to substitute. अकेला sec x है, किसके इक्वल मानेंगे? सब्स्टिट्यूशन आ भी जाएगा. Do something for it special, which will be I am multiplying this term sec x with sec x plus tan x. sec x plus tan x. You will think ये आपका सर complete learned क्या होगा? Yeah, it is learned, and you will also do the same thing for the some cases. ऐसा नहीं होता कि किसी क्वेश्चन की कुछ स्टेप्स फिक्स होती हैं तो आप इस टाइप से जज कर सकते हैं. एक्चुअली क्या होता है कि ये स्टेप इस क्वेश्चन को बहुत इजी बना देगी. कैसे? जस्ट ओपन द ब्रैकेट. I is equals to sec square x plus sec x tan x upon sec x plus tan of x into dx. And we know that the differentiation of this is equals to this. Let sec x plus tan x is equals to t, and from here differentiation of this is sec x tan x plus sec square x into dx is equals to dt. Differentiation of sec x is sec x tan x plus differentiation of this is sec square x is equals to dt upon dx, and after the cross multiplication dx comes in this linear function. On apply both the values in equation number first. From equation first. What is the equation first? Equation first is this sec x plus tan x, which is the denominator will become t. Then I is equals to t. I is equals to t, and the whole of the numerator term, this one, will become dt. So now our function will become I is equals to log mod of t plus c. Finally, we can say that I is equals to log modulus of t. Modulus of t is here sec x plus tan x. Sec x plus tan x plus c. So it is the next formula to calculate the integration of sec x. And now the last, cosec x. It is an integration, so assume I is equals to under root of cosec x dx, and again the same process. I am multiplying this step by into cosec x plus cot x. And now consider that it is equals to t, because differentiation of this one is equals to this one. So let's open this also. I is equals to cosec square x plus cosec x cot x upon cosec x plus cot x dx. Now proceed next. Now assume that this is equals to t. Let cosec x plus cot x is equals to t, and differentiation of cosec x is minus cosec x cot x, and differentiation of cot x is minus cosec square x and then dx is equals to dt. I am taking minus as common, and after it I will divide by minus to dt. So result is cosec x cot x plus cosec square x into dx is equals to minus dt. Now apply both of these values, this one and this one, in the equation number first. So our numerator will become minus dt, and denominator is t. Then I is equals to, from equation first, I is equals to integration of, it is minus dt upon t, implies that I is equals to minus log of t plus c. Finally, I is equals to minus log mod of t, and t is cosec x plus cot x. Okay, student. So these are our 4 formulas. We will copy in your notebook. And let's start the exercise remaining question. To the power 4x dx. So first of all, consider that let I is equals to cos to the power 4x dx. I is equals to cos to the power 4x dx. Now, what we have to write now? We do not have the direct identity to solve cos to the power 4x. Now we will split the powers in formation of square. So we can write from here I is equals to cos square x to the power 2 into dx. Cos square x to the power 2 dx. And in the integration, just remove the squares as much as possible. So to remove the square, we know that cos 2x is equals to 2 cos square x minus 1. And from here, cos square x is equals to cos 2x plus 1 upon 2. So just apply this identity at the place of here. I is equals to 1 plus cos 2x upon 2 whole square into dx. The next step is open the bracket. I is equals to 1 upon 4, I will take outside, a square plus 2ab plus b square into dx. Again, cos square x, the same process, implies that I is equals to 1 upon 4, 1 plus 2 cos 2x plus 2 cos square 2, cos to the power cos 4x upon 2 plus 1. According to this cos square x, then cos 2x plus 1, and here 2x will come, then it will become double. So cos 4x plus 1 upon 2 into dx. 2 is LCM, so take it out. I is equals to 1 upon 8. 2 plus 4 cos 2x plus 1 from here plus cos 4x into dx. Now 1 plus 2 is 3, implies that I is equals to 1 upon 8, 3 plus 4 cos 2x from here plus cos 4x dx. I is equals to 1 upon 8. Now it will become 3x and 4 sine 2x upon 2 and sine 4x upon 4 plus c. Okay students, cancel by this, implies that I is equals to 1 upon 8 3x 2 sine 2x plus sine 4x upon 4 plus c. So it is the answer of our question. So please copy it right now. Now I am going to tell you the next part B. Part B is sine cube x dx. Sine cube x dx implies that I is equals to sine cube x dx. Again, it is the problem. Here power contains by the sin x, so we will try to remove the cube. But we have one identity which is sine 3x is equals to 3 sin x minus 4 sine cube x. Okay student, 3 sin x upon 4 sine cube x. Now the next is sine cube x from here is equals to, it will come here and it will go there, then 3 sin x minus sine 3x upon 4. So apply it here, then I is equals to this one, 3 upon 4 sine x minus 1 upon 4 sine 3x into dx, and the reason for behind it is this. Clear? Next step. Now integrate directly. I is equals to 3 upon 4 minus cos x and minus 1 upon 4 minus minus cos 3x upon 3 plus c, implies that I is equals to 1 upon minus 1 upon 4 कॉमन ले क्या 1 upon 4 ले लो, minus minus plus, then cos 3x upon 3 and minus 3 cos x plus c. So it is the answer of the part B of question number 8. Okay student, in this video we will do till here, till up to the 8th B, and the remaining part we will solve in the next video. And if you have any doubt regarding to any question, so please you can comment in the comment box.